see if any other type of exercises that I can show you. Oh yes, see more. Now I'm going to show you some exercises involving the exponential equation. Okay. Let's start with something easy. Again, solve for x. I got this. 2 to the x equal to 10. Solve for x. Whenever you guys see the variable x on the exponent, think of applying the log on both sides. And the advantage of that's going to help us to bring the exponent down. So if I have this equation, I apply ln on both sides. You got ln of 2 to the x equal to ln of 10. Now the ln means log base e, right? And what is so good about ln? The log in here. It allows us to bring the exponent down. So this is x times ln of 2 is equal to ln of 10. Or x equal to ln of 10 over ln of 2. As mathematician, I'll stop right here. If you guys do your homework, they may ask you to plug down those numbers in the calculator and give decimal solutions. Could be 2 or 3 decimals. Just follow the instruction. But in math, that's good enough. Okay, let's try one more. This time it's going to be a little bit harder to get more complicated, little by little. Okay, try another one. If I have this, 5 times 2 to the 3x minus 1 equal to 8. Solve x. All right, same idea. I see that x on the exponent, so I'm thinking of having a log on both sides. You can choose any base for the log you like. I choose base e because it's more natural. Okay, ln of 5 times 2 to the 3x minus 1 going to be equal to ln of 8. You can actually choose like log base 2. That would work too. Okay, log base 3, log base 2, log any base. I see that because 8 is like 2 to the third. We choose base 2. Let me just do ln. All right. And keep in mind that what number 5 right here doesn't have an exponent, but this is the product of 2 factors, 5 times the exponential form, okay? But we can break it out. A product, log becomes of ln of 5 plus ln of 2 to the 3x minus 1 equal to ln of 8. You guys see that we don't have the exponent on the 5, so we only have a 5. Exponent 3x minus 1 only apply to the base 2. So don't put the exponent on the 5 because this is a very common mistake that we have. All right. So that ln of 5 can be simplified by moving to the right hand side, subtracting ln of 5. And on the left, I got ln left, so I can bring the exponent now. 3x minus 1 times, in parentheses, okay, times ln of 2 gonna be equal to ln of 8 minus ln of 5. You see what I'm doing in here? 2 steps. First, I subtract ln of 5 on both sides. Second, I can bring the exponent down. Okay? And keep in mind, we try to solve x. And actually, I claim that this is no more than a linear equation. So, the safest way to solve x here, first of all, we try to distribute the ln of 2 in the 2 terms. So on the left-hand side, I got 3x ln of 2 minus ln of 2 is equal to ln of 8 minus ln of 5. On the right-hand side, I keep the same. I didn't do anything. On the left, I'm distributing ln of 2 into the 2 term. Here's another common mistake that I've seen. What? People forgot the parenthesis, and then they only have 1 times ln of 2. But actually, the log base E2 right there apply to 3x as well. Distribute ln of 2 to 3x and ln of 2 to 1. You have this. Okay. Keep the term with x on the left. You can move ln of 2 into the right. You got 3x ln of 2 equal to ln of 8 minus ln of 5 and plus ln of 2. Okay? Now what? Divide both sides by 3 ln of 2. You have the answer. So x equal to ln of 8 minus ln of 5 plus ln of 2 all over 3 ln of 2. And I will stop right here, but in the homework, they may ask you to plug this fraction into your calculator and find solution. So, 8 minus ln of 5 plus ln of 2 in parentheses, and then divide by 3 times ln of 2. Hit enter. You should have a decimal answer. Okay, now let me try one more. So let's say we're gonna show you a more and more complicated problem. It's same idea. Now this 2 to the x plus 1 equal to 5 to the 1 minus 3x. Okay, solve for x. I see that in this particular exercise we have x on both exponents on the left hand side and the right hand side. And same idea, we're gonna bring the exponent down by applying the log on both sides. And as usual, I'll do log base e, right? So ln of 2 to the x plus 1 equal to ln of 5 to the 1 minus 3x. And the advantage of the applying the log is it allows us to bring the exponent down. So x plus 1 times ln of 2 is going to be equal to 1 minus 3x times ln of 5. Okay? The left hand side exponent x plus 1, bring it down, times 2x. This whole exponent right here, bring it down, put it in front. This is the whole exponent on the right hand side, put it in front. I have this. Now I'm going to simplify by doing some distribution. We got x ln of 2 plus 1 times ln of 2 is ln of 2 equal to 1 ln of 5, ln of 5 minus 3x ln of 5. Okay? You solve for x. And I claim this is really a linear equation. The thing is we have x on both sides, left and right. So I'm going to bring all the terms with x to the left. I'm going to bring all the terms without x to the right. So I'm going to add the 3x ln of 5 on both sides. Add the 3x ln of 5 on both sides. I have x ln of 2 plus ln of 2 at 3x ln of 5 will be equal to ln of 5. Okay? So I bring all the x terms on the right, and to the left. Sorry. Now, next we're going to subtract ln of 2 on both sides. So bring this doesn't have an x in it, so I'm going to bring it to the right. X ln of 2 plus 3 ln of 5 equal to ln of 5 minus ln of 2. I am subtracting ln of 2 on both sides. 3x ln of 5. Okay, and here comes a tricky step that helps you to solve it. On the left hand side you see what all the terms with an x in it. On the right hand side you see all the terms without an x in it. Okay? All x terms going to be on the left. Or non-x terms will be on the right. And on the left I can factor out the x. I have x, I factored out the x already. I got ln of 2 plus 3 ln of 5. It's on the left. The right hand side is ln of 5 minus ln of 2. Okay? Now all I have to do is divide whatever I have in the parentheses. So x equal to ln of 5 minus ln of 2 over ln of 2 plus 3 ln of 5. And I will stop right here. Again, if you want to have a numerical solution, look at your calculator. Okay. So I claim that those techniques help you solve like 95% of the exercises in our textbooks. There is one more type that you're going to see, which you cannot apply the log on both sides. It's going to be a quadratic. You guys are going to see this. Let me give you an example. See that more when you get to pre-calculus and calculus. How about this example? 3 times 4 to the x, okay, plus 4 times 2 to the x, and plus 8 equal to 0. You see what? We have addition right here. Right? If you apply the log, you cannot break it down because it's not product, it's addition. You cannot simplify. And for this type of problem, they have to set up the problem very nicely so that you can do a substitution. And then you're going to see a quadratic equation coming out. So in this problem, if you let u equal to 2 to the x, and you know that u squared is equal to 2 to the x squared, which is 2 to the 2x, which is 4 to the x. That's the trick right here. So this problem is what? You have see right here like 4 to the x and 2 to the x. That number will always be the square of that number, so that you can do a quadratic equation coming out. This is going to be what? 3u squared plus 4u plus 8 equal to 0. All right? See, you convert from exponential equation back to quadratic. And this type of problem, do not apply the log on both sides, okay? Try to factor this out, see what you got. I think this is factorable because I copied from the book. It should be I don't know. If not factorable, then you have to do a quadratic. I don't know how to factor this. Let's see. So let me do quadratic formula. Okay. Quadratic formula say what? U is equal to negative b, so negative 4 plus or minus square root of b squared minus 4ac. So b squared is, did I copy it right? This, yeah. So b squared minus 4ac, so b squared minus negative b plus what? Square root of b squared is 4 squared minus 4 times 3 times 8 over 2 times 3. This is going to be a negative number, so if you don't have any solution. Negative 4 plus or minus square root of 16 minus 12 times 8 is what? 96 equal to 6. So going to be imaginary, so no solution. Make sure I copy it right. Yeah, it's no solution. Okay. And try another one that has solution then. Look for another one. Same type. Show you. One more. Three to the 2x plus 2 times 3 to the x. Okay. Minus 3 equals 0. And this problem, I'll let u equal to 3 to the x. So this one is going to be u squared. So u squared is 3 to the x squared, which is 3 to the 2x. So this problem becomes what? U squared plus 2u minus 3 equal to 0. Try another one. I just make up one problem that's have solution instead of using the exercise in the book. Okay, so what? I convert from the exponential equation back to the quadratic, and I can try to factor this out. If you cannot factor, then you have to use a quadratic formula. Okay, so surprise, this problem can be that hard. But factor that out. I got this one is what? X plus 3 times x minus 1 equal to 0. So I can have two solutions. Okay. Oh, not x. Sorry, this is going to be u. U. Factor the u, so this is u. So u is equal to negative 3, or u is equal to 1. Write that one more clear. U plus 3 equal to 0, or u equal to negative 3. Second factor is u minus 1 equal to 0, or u equal to 1. Okay? We have to solve first, okay? Your u is just the intermediate variable. So if u equal to negative 3, that means 3 to the x equal to negative 3. That will never happen because 3 raised to whatever equal to a positive number. That's not a good solution. U equal to 1 means what? 3 to the x equal to 1. How you solve x from here? Well, applying the log on both sides, right? ln of 3 to the x equal to ln of 1, which is 0, right? So x times ln of 3 equal to 0, so x equal to 0. You can see right here, 3 to the 0 is equal to 1. So actually you have a solution, x equal to 0. And this is a good solution. So you guys see that log function is, in my opinion, is the most important topic that you guys learn in college algebra. And I guarantee you guys that you're going to use them again. You're going to see them again when you move on to the next level, which is pre-calculus, and then you use them again and again in calculus course. So that's why they split it up to like 3 sections. 6.4 all the way to 6.6, and I show you various multiple types, various type of problems in here. That's you will see in your homework and in your way of study math later on. So please take a look at those. Okay. If you have any question, of course there's going to be more exercise, maybe more different types. I don't know, but at least those are the most basic ones that I can bring up to you. Please ask if you have any question. Let me know. Anything that I can help you with, that I'll try my best to help you. All right, I'll stop the clip right here. Thank you very much for watching, and have a good day, everyone.